Good morning everyone. Today I will share the project presentation on the topic of non-routine problem. We will explore the word of non-routine mathematical problem and how we can use the computational thinking to master them. Okay, so now let's start with the basic. What is actually a non-routine problem? A non-routine mathematical problem is a problem that cannot be solved immediately using a familiar formula or standard procedure. There are many characteristics of non-routine problem. The first one is the solution method is not immediately obvious. The student must interpret the problem, and it requires students to explore, guess, test, and refine strategies. Then the multiple strategies may exist, and it requires creative and logical thinking, which is the higher order thinking, and require reasoning and justification. It often involves real life situation, and it also may have more than one possible solution. It do not have a direct formula or standard formula for non-routine problem. And what is difference between the routine problem and non-routine problem? The routine problem have fixed procedure, but the non-routine problem do not have fixed method. The routine problem is lower order, which is apply the formula in the problem, but the non-routine problem is high order, which need analyze and create the problem. The routine problem usually have one answer only, and the non-routine problem have multiple possible answers in the problem. And routine problem use non-formulas, and non-routine problem requires new strategies. Routine problem focus on calculation, non-routine problem focus on reasoning and thinking. Example of the routine problem is solve the 2x plus 3 equal to 7, so we solve the x. But the non-routine problem is plan the best route with constraint. Okay, now let's see one example for non-routine mathematical problem. The question is, a student can carry a maximum of 5 kg in a backpack. The student wants to maximize total usefulness value when selecting the items. The constraint is, select item with total weight must be less than and equal to 5 kg. We need to maximize the total value and identify all optimal solutions. Then we justify the final choice. The items have book, which have 2 kg and 4 value. The laptop have 2 kg and 10 value. Water bottle have 1 kg and 6 value. The power bank have 1 kg and 8 value. Why this problem is non-routine problem? It is because there is no direct formula to solve it, and multiple components must be explored. There are more than one optimal solution. Students must justify and evaluate the decision, and require critical and analytical thinking in this problem. To solve this problem, we apply and construct a heuristic solution that using the computational thinking, which consists of apply decomposition to break the problem into manageable parts, and use pattern recognition to identify similarity or structure. We apply the abstraction to focus on relevant information and ignore the unnecessary information. And next, we design the algorithm step to guide the solution process. And last, we apply the logical reasoning and evaluation to justify the decision. First, we use the decomposition. The meaning of decomposition is break the problem into smaller parts. We break the task down by identifying the weight and values of every item. Then we list every possible combination that I have listed at the right, from single item to pairs and even group of 3. By breaking it down this way, a big guessing game becomes a structured list of options to calculate, and we need to calculate the weight and value for all possible combinations only. Now, we move to pattern recognition. The pattern recognition is the process of identifying similarity, trends, or regularity in information so I can understand or predict something more easily. On this slide, I have identified two useful patterns. First, I flag our high-value item, which is the laptop, which contribute a value of 10, and a power bank which contribute at second. I noticed that an efficiency pattern. Combining the several small or medium items can often match or even exceed the value of a single big item. To test this, let's look our value comparison table, which is at the right. We combining the laptop, power bank, and water bottle. We reach a value of 24 while only using 4 kg of our 5 km limit. Then we combine the laptop, power bank, and book. We reach the 5 kg and 22 value. And last, we combine the laptop and bottle and book, reach 5 kg and reach the 20 value. Next, we apply the abstraction. This is the critical process of removing unnecessary details and focusing only the important information needed to solve a problem. In our backpack scenario, we must look past the physical object and see only the data that impact our goal. On the left, you can see what we focus on, the weight of each item in kilogram and its value. These are our functional constraints. On the right, notice that what we ignore. We don't care about the brand, the size, and the appearance of or color of the item. By abstracting the items into simple numbers, we turn a complex real-world decision into a clear mathematical task that is much easier to manage. Okay, now let's see the heuristic step 4, which is the algorithm design. The algorithm design is the process of creating a step-by-step set of instructions to solve a problem or complete a task. First, we list all items with their weight and value, generate all possible combinations of items, calculate the total weight and total value of each combination, remove combinations that exceed the 5 kg limit, compare the total value of all valid combinations, identify the maximum value obtained, and check if multiple combinations produce the same maximum value. Last, justify the final optimal solution. Finally, we arrive at the last step, which is the heuristic step 5, is logical reasoning and evaluation. The logical reasoning is the ability to think clearly and make decisions based on facts, rules, and evidence. The evaluation is the process of checking and judging whether something is good, correct, or work well. Looking back at our table, we compare our valid combination systematically. We see that the combination of the laptop, power bank, and water bottle give us our highest value of 24. The other combinations, such as including the book instead, result in the values of 22 and 20. So, we ignore the last solution, which is the laptop, bottle, and book. However, in non-routine problem, we must remember that there is often no single perfect solution. We must evaluate based on our specific constraint. In our priority is the absolute maximum value. The first option is the winner, but if we had other reasoning like needing the book for a class, we would have to justify that decision. By using this systematic approach, we have turned a tricky, non-routine problem into a clear, justifiable choice, and that is the power of computational thinking. To conclude, let's look at our final answer. Through our systematic evaluation, we have identified two very strong solutions. The solution 1 is include the laptop, power bank, and water bottle. It gives a total value of 24 and weight only 4 kg. Solution 2 swaps the bottle for a book, giving us a value of 22 and a weight of 5 kg. Both solutions are acceptable because they both stay well under our 5 kg limit. However, they represent different strategies. Solution 1 focuses on the highest possible value, while Solution 2 includes a higher weight item like the book. Ultimately, I suggest Solution 1 as the optimal choice because it provides the highest value while remaining the lightest at under 5 kg, which is the 4 kg. This result perfectly demonstrates the flexibility of non-routine problem solving. It is not just about finding a number, but about choosing the best strategy based on the evidence we have. Now we see the relationship between the computational thinking and non-routine problem solving. And the first one is how computational thinking supports a systematic and meaningful problem solving. Computational thinking provides a structured approach that helps students solve non-routine mathematical problems in a systematic, logical, and efficient way. The first one is the decomposition. The decomposition breaks a complex problem into smaller, manageable parts and helps students to understand the problem step by step. In non-routine problems, the problems are often complex and unfamiliar, and the decomposition makes them less overwhelming. And the second is the pattern recognition. Pattern recognition helps to identify similarity, trends, or repeated structure, and it helps students use prior knowledge to guide the solution. In non-routine problems, students can connect new problem to previous experience. This will reduce the random guessing. And the step 3 is the abstraction. The abstraction only focuses on the important information only and remove the unnecessary detail and information. In non-routine problem, the abstraction can help students avoid the confusion and makes problem solving clearer and more efficient. And the step 4 is the algorithm design. Algorithm design develops a step-by-step strategy to solve the problem. Ensure the process is organized and repeatable. In non-routine problem, there is no fixed formula, and algorithm design helps create a structured solution path. And the last step is the logical reasoning and evaluation. This analyze and compare different solutions, justify decision using evidence and reasoning, and this evaluate whether a solution is valid or optimal. And in non-routine problem, there are maybe multiple possible solutions, and the student must explain why their solution is correct or better. And the student do not rely on memorized formulas only, but instead break down the problem, identify pattern, focus on relevant information, and ignore the unnecessary information, and develop the systematic strategies. And the question 2 is how heuristic led to new understanding or insights. And the first one is the encourage the exploration. The student will try different approaches in non-routine problem and not limited to one method only. It leads to discovery of multiple solutions. And second is it can promote deeper understanding. Students will understand why a method works and not just how to get the answer. And the number 3 is the develop flexible thinking. The student will adapt the strategies when one method fails, and it encourages the creative problem solving. Besides that, it will reveal multiple perspectives. Different students may use different strategy in the one problem, and it leads to comparison and discussion between the students. And the last, it can strengthen the decision-making skills because the student will evaluate which solution is more efficient or more practical or more logical. As a result, computational thinking helps students become independent and flexible problem solvers in real-world situations. In conclusion, this project demonstrates how heuristic strategy and computational thinking can be used to solve non-routine mathematical problems. By applying the decomposition, pattern recognition, abstraction, algorithm design, and logical reasoning evaluation, complex problems can be solved in a systematic and meaningful way. This approach not only helps students to find the solution but also develop higher order thinking, creativity, and decision-making skills, which are essential for 21st century learning. This is the reference for my project presentation.